All right, as we fire up semester number 2, we are going to be doing some work with graphing exponential functions. And you're like, wait, some of this stuff might look a little bit familiar, and some of it will be, but some of it is going to be us talking about, once again, patterns that are going to help make our lives go faster. Now, again, there's still some ways we can just kind of plot along here at the start, which is not a bad thing. But in the big picture, if we can figure out some of the patterns, it's going to make our life go really easy and really fast. So here's the deal. We are going to be chatting growth. We are going to be chatting decay. And there's some very small differences between them for us to recognize them without even seeing a graph. And here's what they are. When you're going to be dealing with growth, your base, okay, the value you're taking to an exponent is going to be greater than 1. Now, does that mean it can't be a fraction? No, it could still be 5 over 4, 3 over 2, something like that. Those are still greater than 1. Where if it's decay, it's going to be between 0 and 1. Could be a decimal, could be a fraction. But again, just because it's a decimal or fraction doesn't mean it's going to be, less than 1. So that's the main thing to look out for. Check out that b value all the time. Everything else almost that you see here is going to be the same for both. The function is continuous. There are no holes here. We've chatted about those a little bit in the past. 1x for 1y. We've talked about that with your domain and range. And again, in growth, it's increasing. It's getting bigger as you go to the right. Decay, continuous, yep. 1 to 1, yep. And decreasing, getting less as I go left to right. But again, a lot of similarities. The domain is the set of all real numbers. Now, there's 2 ways you can write that. You can say negative infinity to infinity. We've done that before. Or you can use that double barred R to say all reals. Okay, those 2 things say the same thing. You could even write out all reals if you wanted to. So that's the same on both of these. The x-axis is the asymptote of the graph, but we want to write it as an equation, which would be y equals 0. Because everywhere, even though the x values change along the x-axis, the y value does not. It's always going to be 0. So that's the same for both of these. The range, and for some reason, in my changing around of things, I messed up one thing. I know, you're shocked. You're shocked. This should say of all, I want to make sure, it should read just like this. So let's fix that. Cut and paste is a great thing until it doesn't work. All positive real numbers. So in other words, we start at 0 and we go to infinity. And that's true whether it's growth or decay. Because you'll notice here, yeah, it goes up forever, but as it comes down to the left, it hugs the axis, but it's never going through it. It's never getting to it. That's why we're using a parenthesis here and not a bracket. And we'll see that more when we start graphing. And it's the same with decay. It's going up forever on the left side. But as I come to the right, it's getting closer and closer to the x-axis, but it's not going to cross it. So that's the same on both of these. And the y-intercept, again, until we get into shifts, yep, they're coming again, will be 0, 1. But there's going to be a pattern to that as well. But that's just the basics, okay, our parent or our base function. So really the only difference between these is the b value telling us whether it's going up to the right and growing or down to the right and decaying. That's it. Okay, the rest of this stuff we'll chat about more as we get a little bit deeper. So classify the function as growth or decay. Now again, they gave me a picture here, so that kind of makes this easy. I'm like, they gave me a picture, I can see it goes up to the right, so that's growth. But why is it growth? If I didn't have a picture, my b value is 3. It's the number being taken to the x power. This doesn't do anything for me on that part. If this is bigger than 1, it's growth. If the b value is between 0 and 1, that's going to be decay, even if I couldn't see the picture. So, very early in this new semester, new unit, I'm freeze framing. Give a shot to number 3 and 4 without having a picture as to if you are going to be looking at growth or decay. And then we'll see how we're feeling here as we go. All right, hurry. 3, I'm comfortable. We probably did okay. Number 4, I'm hoping we treaded carefully. Because 5 over 2 is 2.5, which is still greater than 1. So number 4 is going to be growth, even though it's a fraction. So be on the lookout for that, because that can mess you up if you're not watching out for things. Okay. So as we keep rolling along here, now we actually get to do the graphing. So now, again, this is going to come down to personal preference with people. There's a couple of things I can do before I even get into a graph, and I want you to get into this habit because I want this to be more mental when we're thinking about anything else. What's my b value on number 5? Well, I don't have a lot of choices. 2 is the only number there. So if b equals 2, is this growth or decay? Growth. Okay, so we know with growth, it's going to look like this. So before we even graph it, I'm going to mention one other thing, and then the rest I'm hoping we're going to kind of knock out as we go here. So flashback to end behavior. Hardy, I thought first semester was over. Oh, but it still builds. So with end behavior, we're looking at your graph from left to right. Hardy, we don't have a graph yet. We do, but we don't. So as I'm looking here, we know that it's going to go up to the right like this. So here's what I do know. I know as I'm going to the right, it's going up forever. So I've got this piece. I'm going to leave this piece blank for a minute. Even though with the basics, we kind of know what's coming. I want us to see what's coming before we do this. So I'm going to jump over here. 2 to the x power. That's a new one. So again, here's my exponent button if it's been a while, right above divide. There's my x. So make sure it's 2 to the x power and not 2 times x. That's completely different. So we can take a peek at it for a minute here. Oh dear. Good learning lesson here at the beginning of the semester. I got to make sure we're in standard form. People. Zoom 6, people. Zoom 6 if it's weird. Okay, so there it goes. So, kind of like what we thought it was going to look like. Okay. I'm going to pull my chart for this one simply because, again, I'm going to make note of a couple of things here, though. Now, could I use decimals here? I could. I'm not going to yell at you if you don't. But let's think about this for a minute. Negative just means you're flipping stuff. So if I add 1 and it's 2 and I flip 2, that's a half because this is like 2 over 1. I'm flipping it. If I flip 4, that's 1/4. If I flip 8, that's 1/8. That's what all these decimals are. But again, I might not need the decimals at all. I could probably do all that in my head. And so once I get into here, Notice, even if I were to keep scrolling up on my chart, I'm going to get really, really, really close to 0, but I'm never going to get there. So when you're doing these graphs with growth and decay, it is hugely important that you don't get sloppy with your graphs. I'm even going to take it a step further to help you make sure that you don't. When we were doing the last example, we said that the asymptote is at y equals 0. Okay, I'm going to draw that in on these. It's not asking me to, but I'm going to do it anyway because I want to make sure, because I'm going to watch this like a hawk when we get to this first quiz. If you get sloppy and this goes below the axis, I'm going to be like, This is like the electric fence. We don't go through the electric fence. That's not a good idea. Really close is okay, but don't do it. So that kind of gives me a picture, and now I can do the rest of the information. My y-intercept, again, occurs where x equals 0, 0, 1, just like it's set on the parent graph. My domain, forever to the left, forever to the right. That's kind of familiar. Is that always going to be that way? Every time. Doesn't matter if it's growth or decay. Your domain will be infinite. And your range, now here's where some of you still got to be careful. It's bottom to top, not left to right. So bottom, I'm getting really close to my asymptote. That's why I like to draw it in. That's always going to tell me where my first number is. And we're going up forever. Here comes the first pattern, though, that you're going to be dealing with if you want to make this go quick. When you're doing these, for growth and decay, your domain will always match up, if you're doing end behavior, with the x values over here. It's always negative infinity to infinity, so is my domain. When you go to do your range, that's always going to match up with your end behavior values for your f of x or your y. So, as x was going to the right, we said y was going up, and that's true. And then now we can look and go, oh, so when x is going to the left, it's getting closer and closer and closer to the asymptote, which is 0, and these match up. So it's almost like you're getting a multiple choice of sorts. If you have these, it's 50-50. It's not really when you're doing those. So if you're looking for those little hints or clues to make things a little easier, that's a good way to do it, instead of thinking that's like negative infinity or something like that. And so anytime you're doing a base function like these, that's all you're doing. So for instance, let's play another pattern game. Could I put this in my calculator? I could. I'm not going to, though, because 1/2 is just 2 flipped over, right? So if that's true, these are all just going to be opposites. So just to show you one thing, so you can see where I'm going here. If I do 1/2 to the -3rd, it's 8. Because I'm taking 2/1 and I'm flipping it, and I'm cubing it. If I flip 1/2, that's 2. 2 squared is 4. It's this entire chart just flipped over. If you take 1/2 to the first power, it's 1/2. If you take 1/2 to the second power, if you square each number, it's 1/4. Are you telling me I can't use the calculator? No, you can still use the calculator. I'm just going to try and help you more even this semester than first. Find some of those ways to, number one, shorten the time you got to spend on this, and number two, when you get to quizzes and tests, not stress yourselves out. You're like, well, I still got, 6 problems left with a minute because I'm going back through and I'm using the calculator on all of this. Because now I can roll this, at least I think I can. My b value is a half, which is decay. I see that here. It goes down from left to right. My y-intercept has not moved. We'll see where that's going to start moving here in the next problem. Domain never changes. Now, this again is where some of you need to be careful when you get to range. Range is not left to right. It's not infinity to zero. Range is bottom to top, least to greatest. Least is still 0, because here's my asymptote. And that's still top. My range is exactly the same as it was in my growth. But is that going to change my end behavior a little bit? A little bit. I mean, the x part's still my freebie square because they just match up, x's and x's. But this time with my range, as I'm going to the left, I'm going up forever to positive infinity. And as I go to the right, I'm approaching 0. Still the same two values, just used in a different order. So those are the types of things we're going to have to be aware of, okay, and be cautious of. But if we got a pattern, we kind of have an idea of what's going on with these, and it won't be too bad. So I guess I should pause for a moment. So questions on any of the pieces so far? Because this is where we're going to start changing little bits and pieces as we're trying to get the hang of things here. Not yet. We're still comfy, Hardy. Okay. So, a quick investigation here. This I will break out the calculator for. So, if you want to, oh boy. If you want to just follow me on this one, you can. If you want to play, you can do that as well. I'm going to try to use different colors for every one of these. I'll label them too. So here, I'm actually going to use the chart because I want to get some quick values so we're not messing around a whole lot. So let me get this first one. So I got 3, 8. I got 2, 4. I got 1, 2. I got 0, 1, and then we start getting all decimally here. So, okay, so there's letter A. That's my y equals 2x. It's my base graph. So now, I'm going to keep that one on there. So now we're going to multiply that by 2. I'm going to pull my chart. Like, Hardy, it's like the same numbers. They just, like, moved. So we got 2, 8. We got 1, 4. We got 0, 2. We got negative 1, 1. And then we go back into this stuff, and we're getting really, really close to 0. So it just kind of went up a little more. But here's what I'm going to have you jot down, or what I want you to notice. When we did 2 to the x, my y-intercept was 0, 1. Then I did the next one, and my y-intercept was 0, 2. I wonder if this is a thing. So if we go to C, I'm just going to change. I'm not going to put 3 of them on here at once. That's getting too busy for me. So 5 times 2 to the x. So actually, I want to look at the graph of this for a minute, and then we'll pull the chart back up. So there's my base graph. Here comes 5 times 2 to the x. Notice where it crosses the y-axis. This one crosses at 0, 5. 110. And so I start to look at these and I'm like, they all end up at the same place to the left. But I'm noticing as this A value gets bigger, they're going up quicker and it's changing my y-intercept a little bit. Okay, that seems kind of reasonable. One more. I'm not even going to go through these last two together. I just want to see one more. I got rid of the one I wanted. So if this is -1 times 2 to the x, oh my gosh. There we go. If I look at the picture first, okay, there's my base graph. Here comes my second one. Oh. Go to my y-intercept. My y-intercept is 0, -1. And so what I see is it's a mirror image of my base graph. It's just reflecting about the x-axis. So you probably could tell me what the y-intercept of E was going to be without us ever even typing it in the calculator. What would the y-intercept of E be? 0, -3. And so what I hope you would notice here then would be that this A value, this number that's out in front, does a couple of things. It shifts the y-intercept. Whatever it was moving with it directly. And it causes us to stretch vertically. The larger the number, the faster it stretches. But again, vertical. We'll see a horizontal, just not yet. Okay? And so not only does it shift that and stretch it, depending on if it's positive or negative, if A is positive, our graph opens up. If it's negative, it opens down. I mean, we visually can see that, but now we can kind of think about that in advance as well. And so, is that going to move a few things? Yes. Is it going to change our domain and range right now? No. Is it going to change anything we do with end behavior? No. It's just the y-intercept so far. We talked about that. So the last thing I want to mess with today, we're going to split this into pieces because we're not going to go crazy the first day because that'd be silly. So, we're going to mess around a little bit here. We're not going to go crazy, just going to a little bit. So we're going to take a peek. I'm just trying to think of which ones are going to serve us best. I'm thinking 9 and 8, but we're going to do them in reverse order. Yep, that's what we're going to do. We're going to do 9 and then 8. There's a method to the Hardy madness. Okay, first question on number 9 before we do anything in the calculator. What's my B value? 1/3. So is this growth or decay? Okay, so we got decay. Oh, I got more questions before we punch this in. What's my y-intercept? Coordinate point? 0, 5. Because if I just put 5, that's more like talking about the asymptote, which we're going to do next. What's my asymptote going to be? Still y = 0. Those are the two details we've got to get locked in here today. Intercept is a coordinate point. Asymptotes align. We've got to label them correctly. We can't just put 5 and 0 here, or that's not giving us the whole story that we need. Okay, still not going to graph it. What's my domain? Negative infinity to infinity. What's my range? 0 to infinity. You're like, Hardy, we're like doing everything with this and we haven't even graphed the silly thing yet. Telling you, patterns can be powerful things if you just take the time to get situated with them. Now, this I have to think a little. All I know right now is that this is decay. So I know it looks something like this. That's enough to help me with end behavior. So as we're going to the left, am I heading towards 0 or infinity? Looks like we're going up to the left to me. We're going up to the left. There we go. As we're coming to the right, we're coming down closer to our asymptote. Now, if that part you want to wait until you graph because you like to see it better, that's fine. Not a big deal. Not a big deal at all. So we'll get that typed in because we want some points. We need some points. There's our 0, 5. Good job, us. Now, the rest of this is kind of wonky. It doesn't mean we've done something wrong. You're like, holy cow, Hardy, like, we're not plotting some of these numbers on here. You're right, we're not. Some of this we are flat guesstimating. We are still hugging the x-axis. Do not cross that asymptote. Don't do it. All kinds of trouble for you if you do. So I've got to throw one twist in because this is just a thing we do. Like it always has been something we do. What? I mean, it just is. So here's the twist, because everything else is going to be real straightforward with what we're doing today. What happens? So let me ask a question quick. If we were doing number 8, well, I mean, we are doing number 8. Is this going to be growth or decay? So here comes the twist. Normally we would look at that and we go, well, the B value is 4, it's growth. Oh crap, that looks like decay. So here's what you need to think here. Here's our whole issue. That exponent's negative, it's negative x. So when you see that, here's what's going on in reality. If you were to take what's inside the parentheses and take the reciprocal or flip it, to make that x positive, which is what we're actually doing, your B value would be 1/4, not 4. So if you ever see a negative exponent, fix that right away so you don't get sucked in. Once you get past that, then it's not a problem. Now we can do whatever. We could do what we did on the last one if we want to. Notice that did not change my y-intercept. It's still the A value. It did not change my asymptote. It is still 0. Heck, it didn't change anything else. Let's be honest. So the main point of the lesson today is, if you know your basics, you're not going to get scared into doing something you shouldn't, because you're going to be like, This is always what happens in this situation. And until I'm told differently, which you may be told a few things differently tomorrow. We can make this a pretty good thing. Because what I would hope for some of you this semester, after seeing what you did last semester, is we can get you to the speed part. I'm confident that all of you on the academic part of figuring out what to do with these are good. I think some of you freak out when you see lots of them, though. So that's what we're going to work on. We're going to work on some detail training here. And so all I really got to do, the only thinking part of this entire process, is that first part of end behavior. There's my arrow on the left going up forever. There's my arrow to the right, hugging y equals 0. And we're there. You already, well, I mean, you know partially what I'm going to say for as far as the practice goes, because it's going to run the same way we did it last semester. You've got answers to some in here already. You have answers to some of mine up front. But you're not ready for the entire thing yet. You probably know this already. So what we're going to do is over here, Hardy's going to go into hand-picking mode. So stick with me here for a second. Okay, here's what we're going to do. So for day 1, ooh, this is going to be interesting. Sorry, I'm not playing odds and evens today. Number 1 and number 7 through 12. Because those are the only ones that aren't getting into all the shifts and things that we haven't seen yet, which we will see tomorrow. So number 1 and 7 through 12, you should be able to play with in a nice format and get things situated.